had a request to do number 2. So let's look at number 2. Number 2 says solve the inequality. Go remember that solve is just another way of saying get the variable by itself. So what I saw first here is that the variable, the x, is obviously not by itself right now. And it's one of those compound inequalities where there's 2 statements kind of pushed into one. And so I see that with the x, I've got a -3, and I've also got a -1. And I can handle this in a couple of different ways. Would you guys think it would make more sense to get rid of the -3 first, or do you think I should distribute the -3? What makes more sense to you? Distributing is fine. So if I did that, I get 9 is less than or equal to -3x plus 3, and that's less than 15. All I did was a distributive property. I just simplified it a little bit. Now, if we felt like that was the easier way to go, I've got a -3 that I need to handle, and I've got a +3 that I need to handle. Which one would make more sense now? So I got to subtract 3. There we go. So -3. I've got to do it from all 3 parts, since this is 2 statements in one. So this would give me 6 is less than or equal to -3x, and that is less than 12. And then the last step is kind of the trickiest one. We've got to get rid of that -3. How would you propose that we get rid of that -3? Yeah, and whenever you divide an inequality by a negative, what do you have to do?
You have to flip the thingy.
Yeah, flip the thingy. Yeah, the inequality, right? Gets flipped around, both of them. So this would be -2 is now greater than or equal to, I flipped that inequality, x, which is now greater than -4. This gives me my 2 key points that would go on my little number line there. The first one is -4. First one is -4. It's an open circle. The other one is -2. Be a filled in circle. I'd connect between the 2. Okay, so for those who maybe were wondering about that one, I hope I did a great job. But if I've caused you to have more questions or I didn't fully answer your questions, let me know. Anything I can do? We okay? All right. So anybody want to see number 1 done? Yes, excellent. Figured number 1. I'm not going to lie. Number 1's got a lot going on, and I would put it in this perspective. If you can do number 1, I think you're really good at order of operations. I think you're really good. So if you fell a little bit short, let's just keep getting better. Don't look at that as a final judgment on you. We're just basically trying to see where you're at. So what I would do here is I would do my empty parentheses procedure like we've always done. So it'd be 4 minus empty parentheses times -4 empty parentheses plus absolute value of 5 empty parentheses, quantity squared, don't forget that, times 3. So all I'm doing is I'm just replacing all my variables with blank empty parentheses, and now I'm going to fill in those blanks with the appropriate number. So x is -6, and y is 7, and x is -6. So at this point, I've just filled things in. This is where really the meat of this happens, where PEMDAS needs to happen. I want to be super careful. In math, do we read from left to right? No. What's the order we read in? PEMDAS. Okay. So I've got to do the work in the parentheses first, right? That's the P in PEMDAS. So I'm going to ignore the 4. I'm going to ignore the minus -6. I'm not going to touch that because I'm reading according to PEMDAS. I've got all this stuff in the parentheses here that I got to handle first. So -4 times 7 is -28. What's 5 times -6? But then we're going to do the absolute value of that, so it's really 30. Okay. Still going to ignore the 4 minus -6. -28 plus 30 is 2. So at this point, I've completed all of the work that I can within the parentheses. What comes after parentheses in PEMDAS? Exponents, somebody said. There we go. So exponents, so I'm going to write 4 minus -6. Is that driving anybody crazy that I keep just writing 4 minus -6? A lot of people, they want to do something with that. They want like, oh, it's 10 or something, but it's not, is it? You got to read according to PEMDAS, so be careful. Okay, so I squared the 2 and I got 4. So I've completed my parentheses work. I've completed my exponents work. Next thing, of course, is multiplication and or division. So I got a bunch of multiplication over there. So it's going to be 4 minus, and this might have been a tough multiplication. Negative 6 times 4 is negative 24, times 3 is negative 72. And that, of course, is 4 plus 72, and that's where I got my 76 from. Okay, so I am guessing that more than one or two folks maybe wanted to see some details in there. And like I said, when you were working, I saw a lot of folks that were really showing some really meticulous, good work. Maybe there was a mistake in there somewhere, but your communication was good. Again, let me just ask you, I hope that my presentation for the last couple of minutes has been clear, but if I've caused more issues or if I didn't answer your question, please let me know. You're not going to make me feel bad. I know sometimes it just doesn't click, so let's try to make it click. All right. So then the other thing that I noticed that was encouraging to me was that as I walked around, I noticed that a lot of you guys were really making some nice progress with number 4. I don't think we're completely 100% of the way finished with this concept, but I feel like we've made progress, right? We're doing better than we were yesterday, so that's good. Let's keep working at this. So this says use elimination to solve the system. What is a requirement for elimination? Like, what do you have to have within your system somewhere? Okay, like a negative and a positive, which it kind of looks like subtraction, right? I call it the pattern of opposites, like 7 and negative 7, 12 and negative 12. Do you all see, can you tell if the x's or the y's have the pattern of opposites right now? What are the coefficients on the x's? They're both 1. Is 1 and 1, are those opposites? No. And then, of course, 8 and negative 4, also not opposites. So we need to make the opposites happen here. And there's 2 ways to do it, at least 2 ways to do it. Suggestions. What did you do? Those that feel good about how you completed this one. You want to share? Sophia? So let's say multiplication, right? Because I want to be consistent with what I said before. So you essentially multiplied the bottom row, was it, by negative 1? That's what subtraction is anyways, right? So if I multiply this through by a negative 1, I would get the top row still, and then the bottom row would be negative x plus 4y equals negative 1. You see how, based on what Sophia just said, now we have the pattern of opposites with the x's. Now I can just add my like terms. X plus negative x is 0. Those have been eliminated. Here I get 12y equals 6. This is where I mentioned the fraction thing. Some folks got a little uncomfortable with this. If I then divide by 12 on both sides, I get y is equal to 1/2. And this feels like I'm done. Why am I not done? Got to find the x to go with that. Yeah. How do I find the x to go with that? Plug in. There you go. I've got choices. In fact, I'll highlight them for you. I've got a green choice. I've got a red choice. And I've got an orange choice right there. Of those 3 choices, which one do I have to plug back into? I can plug into any of them. Which one do you think is going to be the easiest? I think green. I think green makes a lot of sense. So plugging into green would give me x plus 8 times 1/2 equals 7. Of course, that's x plus 4 equals 7. Subtracting the 4 from both sides, x is equal to 3. My final answer would be 3, 1/2. Had a couple of interesting conversations with folks as I walked around the room. Does anybody know how you could check your answer to see if that indeed really is the solution to the system? Yeah, plug it into both, right? Yeah, so you could come back here, and we could just do this mentally. Check this out. If I plug in here, wouldn't it essentially be 3 plus half of 8? 3 plus 4 is 7, and look, equals 7. So it checked. The other one would be 3 minus half of 4. So that's really 3 minus 2, and oh my goodness, that really is 1. Because that point worked in both, it tells me I feel pretty good, I got it right. So it'd be a way to check. Okay, so again, hope this went well, but if I've messed you up somehow, or maybe you still have a question, let me know. Okay, good deal. All right, so I think, in my opinion, the thing we're going to talk about today is one of the most important things. Have you ever asked the question, when am I ever going to use this stuff?
Yes.
I have a question for you. The last time you were playing video games, did you ever ask yourself, when am I ever going to use this stuff?
No.
Oh my gosh, you should always ask that, right? In any case, I don't think anybody could debate that what we're about to do today and tomorrow is something that you could apply to your life this afternoon, or in 1 hour, or next week. It's all about percent. You need to know how to handle percent, both the easy variety, the medium, and the more difficult. Okay? Percent. I bet you can't go the next week without hearing the word percent mentioned multiple times, right? What's that again?
I said bad. I was joking.
Anyways.
No, I hear that like every day.
I would hope so. Even out of the context of school. I'm not even talking about, hey, I made a 74% on my quiz. I'm not even talking about that. I'm talking about read something on the internet, watch the news, listen to something on the radio, or whatever it is you do. Eventually, you're going to hear, oh, well, 5% of this, or there was a 25% increase. Do you even know what that means? Maybe you do. Let's make sure you do. Okay? So here we go. I hope, I know that roughly slightly more than half of you followed through on the intro video. It was to make sure you know how to convert from decimals to percents and so on and so forth. I want to do a couple of examples with you, and I want to present a certain way of doing these. And I just want to give you a full disclosure. I am completely aware that what I'm about to show you is not the way that every single person has learned or teaches this. I get it. So, if you have a way that works awesome for you, I know that there's several of them, and you're awesome at all these percent problems, I am not going to try to get you to do something different, right? But if you've never seen this, or you are not doing very well, I'm going to push you towards this, because this is a little bit more real world than a magical proportion, right? The goal here is to get you to understand what's happening, and so I'm going to attempt to do that. Okay, so there is a slight element of translation involved in these, but it's really, really easy. There's only two words that we need to really look out for. Is and of. What does the word is almost always mean? Equals. Yep. So if you see the word is, or any version of the word is, like was, right? So the past tense of is, you want to think equals. And then what about the word of? It almost always means multiplication. There we go. So I'll just put a little dot there to indicate multiplication. So what I want to do here is I want to just give you an example of how this would work. And then I'm going to just set you guys loose and see if you can do as many of the rest of them as you can. We'll come back together, check some answers, and see how it's all going. So I thought I would do number one here kind of with you first. So let's make sure that we're translating this well. The first two words I see are right here. It says, what number? So clearly we don't know what this number is. And in math, if we don't know what some quantity is, how do we usually represent it? A variable like x, n for number, something like that, right? I'm going to go with, I'll go with n for number, if that makes sense. So I'm translating, and I'll use colors. So the orange highlighted phrase, what number, we're going to translate that as just an n. And then the very next word is one of our really key words, is. And what does is mean? It means equals. So far here is my translation. Try to color code it. Make sense how they go together? So from the intro video, or perhaps from your past, 28% really would be better written as a decimal here. And what would it be as a decimal? 0.28. Yep. So 0.28. So I'm getting that, of course, from right here. Oops. From right here. And then how about that next word? Of. And what does of mean? Multiplication. Oops. I I keep messing that up. There we go. So I'm just going to put a little purple dot to indicate I'm multiplying. And then it doesn't require a whole lot of translating to get that 39 where it goes. So n equals 0.28 times 39. So this would be a time when a calculator would come into play. So when we do our quiz that involves percent and the test later on that involves percent, we'll definitely have a calculator. So please, if you've got one with you this morning, grab your calculator and let's figure out what 0.28 times 39 really is. Of course, this is doable without a calculator, but from a timing perspective on a quiz or a test, I would just have you use a calculator to figure out the details of the arithmetic.
Would it make sense to
11.
Is it exactly 11?
No, it's 10.292.
So it says round to the nearest tenth. So say again, 11 point what?
10.92.
10.92. Okay, so we bring up a really good point here. So when it says round to the nearest tenth, I am not going to be a hyper stickler on this, but I do want to tell you how I'm going to do this, right? The tenths place, what number is in the tenths place up there? The 9.
Yeah.
The 9 is in the tenths place. So I want your answer to be accurate to the tenths place. So if you wrote 10.9, I'm good with that. So I'll put blue boxes around things I'm good with. 10.92, isn't that still accurate to the tenths place? However, if you put 11, I'm not going to be okay with that because that is not accurate to the tenths place. Do you see what I'm getting at? So please be really careful with the rounding. It would always be better to include more decimals than to over round, right? Because we could always round back down if we needed to, but if you go too far, then you've just gone too far. So be careful with that. Okay. I hope that system of translating makes sense to you. I want you guys, again, using your calculators here as needed, I want you guys to run through as many of the rest of these as you can. There is number 2 there, of course. And then I think there's 3 more on the other page. 3 more. And they kind of go in, I don't know, once you get into numbers 4 and 5, they get a little bit more challenging. So I want you guys to try. At least get to a place where maybe you've attempted 2 and 3. Right? If you can do 2 through 5, that's great. Let's see if you can get 2 and 3 down as well. I'll be around to help you. Was 10.9, right? 10.9. So I want to be, hey, Mason, this is a bad time to be distracted. And you're talking to either Elle or Caroline. So, man, I'm doing my best to be clear. Okay. I want to make sure you all understand this. If I was doing number 1 and it was on a concept quiz or it was a test, and here's exactly what I wrote. If I wrote 10.9, are you listening?
Yeah.
If that's the extent of what I wrote, I'm not getting any credit at all. I need to see where, no, that's not a percent. I need to see that you actually know where that came from. So this would earn, and I'm not kidding, no credit at all. That's the right answer, I get it. And I do care about the right answer, but I care a whole lot more about your thought process because in 10 years, whether you got 10.9 or not, frankly, is not going to matter. If you've built logical thought processes in your mind, that might matter in 10 years, okay? I'm trying to think long term. I'm trying to think, gee, when am I ever going to use this? That's what I'm thinking of. No one cares that you got 10.9, even if it's the right answer. It just won't matter in 10 years. If you are logical and you understand and you can use your mind, that very well might matter in 10 years. So here we go. I would want to see n equals 0.28 times 39, therefore n equals 10.9. That would receive full credit because I'm actually seeing the little parts that you used to get to your answer. Make sense? So number 2. I know we didn't do this one yet. This is a straight translation, so I will translate. 52. What does the word is mean?
Equals.
It means equals. That's right. So There is my equal sign. 120%. I would write that as a decimal. And what is 120% as a decimal? It's 1.2. That's right. How about the word of?
Multiply.
That is a multiplication, yeah. So of means multiply. So there's that. And then what number? That's going to be our unknown. And so I'll just put that in. I'll put that in as an n because it's a number that I'm looking for. So this step, or some other step similar to it, must be on your paper. And if you want full credit. So if I'm solving for n, what's the algebra step I need to do? Division, yeah. Division by 1.2. So I get n is equal to 52 divided by 1.2. And is that 43 number that I saw?
43.3.
Okay, so 43.3. Rounding to the nearest tenth, 43.3 is equal to n. Can I show you something that would not receive full credit? Are you watching? Please, watch. Remember, this is an algebra class. So if I saw this thing on the right that I'm about to write, if I saw 52 divided by 1.2 is 43.3, and you circle that and you say that's my answer, that will not be receiving full credit. There is absolutely no algebra shown whatsoever. That's arithmetic. And as you know, the class is not called Arithmetic 1. It's called Algebra 1. I want to see that you know how to do a little bit of algebra to get to an answer like this. And this will serve you well as we move forward. Any questions on 2? Questions? It would be horribly unfair of me to expect you to do what I'm expecting you to do if I didn't tell you. I'm telling you. This is what I expect. So you can get upset if you want. It's not going to change what I do. So please, take it to heart. Okay, so nobody had any questions there. How about number 3? Number 3. This is where I would say if you're used to just pushing buttons on the calculator, number 3 might have been a moment where there was some struggle. You've got to translate this into an equation. So this says 7. So I'm just going to translate that as a 7. And then what does the word is almost always mean? Yep, so I'm going to write 7 equals. This is where my notation is going to be a tad different. When I see the words what percent, I want to remind myself that I'm looking for a percent. So instead of writing X or N, I'm going to write the letter P to remind myself that this thing has to be a percent. So P, and then I've got that other word that we always see, of. What does of mean? That's multiplication. Oops. And then, of course, it says 183. That one's pretty easy to translate. So, if you were doing a question like number 3 and it was your quiz or it was your test and you're hoping, I'm going to get this right, and you didn't write that, you won't get it right. I don't care what you get for a numerical answer. You won't get it right. I need to see that you've translated into an algebraic equation. Okay, so what do I need to do to solve this thing? Just one step, right? Division. There we go. Divide by 183. And when you do this, you get something like 0.0382.
Yeah.
Is it 382? This is where me writing the letter P is actually really important. I need to remind myself that this is supposed to be a percent, not a decimal. So I'm going to take this over here and I'm going to convert it. I got to move the decimal 2 times, 1, 2. So I get 3.82. Of course, I want the nearest tenth, so it'd be 3.8. And then I got to put that little percent symbol. I can't leave that off. That needs to be there. And that's what I was referring to with yours. You just didn't have that percent symbol. Okay, so again, just kind of a contrast here. If I were to just write 7 divided by 183, and then I wrote 3.8%, I can count on not getting full credit for that, because I didn't show any algebra at all. I showed a little bit of arithmetic, but that's just button pushes on the calculator. I want to see that you know how to do the algebra. Okay, how are we doing? Now, the last 2 are a little bit tougher on the translating side. So let's, and believe it or not, number 4, and to some degree number 5, is going to be a little bit about math for sure, but it's mostly going to be about English, believe it or not. So number 4, The is and the of are not quite as clearly spelled out, are they? It says 18 people showed up for the party. Okay? If this was, now this is the first English lesson, isn't the word this, I'm going to scare some of you, isn't the word this a pronoun?
What?
This is a pronoun. This word right here is a pronoun. And pronouns always refer back to something else, don't they?
To the object.
To some kind of noun, maybe a subject or something. So when you see the word this, what is the word this actually calling out?
Was.
No. Somebody said it, I think. What? 18 people. Like, 18 people showed up for the party. Great. If this. And somebody's like, well, what are you talking about this? I'm talking about the 18 people. That make sense? Okay. So if the 18 people, and this is maybe a tricky one right here, the word was. What is the word was really?
Past tense of is.
Past tense of is. That's really an equals sign. This is a tough one because we're so kind of keyed in on finding is, but we're really looking for, in this case, was is the key word. So I'm going to say 18 people was, aka is. 18 people equals, and then it says 90%. What do we do with percents when we put it into an algebra equation? Decimal. That's right. So it's going to be 0.9. What's that next word you see? 90% of. And what does of mean? Those that were invited, and we never know how many were invited, and then we look at the end and it says, well, how many were invited? That's the question, isn't it? So maybe I put I'm going to avoid P because that almost looks like a percent. I'll put N for number of people, but you could use an X. I would maybe just avoid P because we're not looking for a percent. How do I solve this? Division. So I'm going to divide both sides by 0.9. And what is 18 divided by 0.9?
20.
So there were 20 people invited, only 9 showed up. Good? The last one. Number 5 says 45%. Well, gosh, I look at that first 2 words. That's a pretty clear translation, right? So 45% would be what?
0.45.
How about the word of?
Multiplication.
And this is where this one gets a little bit tougher because it's 45% times all Valor students. So the question becomes, do we know how many students constitute all Valor students?
Yes.
How many?
1,100.
Isn't it right here? Doesn't this indicate that that's all of the students? So 45% of all students is really saying 45% of 1,160. This is the number of students who do support a change. So did anybody work out the numbers here? Like what's 45% of 1,160? 500 what? That sounds about right. Yeah. So 522 equals N. And this is the trickiest part of this one, because if you stopped right here and said 522, I would say you're not wrong, but you're not done. Because 522, doesn't that represent the number of students who do support a change in the policy? But what did the question ask about? How many don't? So can anybody think of a strategy how I could get to the how many do not? Subtraction. Yes, there we go. So I just go 1,160 minus 522, and this gives me, what, 638? That sounds right. So it'd be 638 do not support. There are other ways to do that one. That way is a fine way to do it, but there is at least one other way. So, guys, good job. Day 1 of percent. Tomorrow we'll delve a little more deeply into percent. Hope you have a great day. See you tomorrow.
Is the concept quiz on Friday about like substitution?
Systems. Yep.
All right, cool.